Okay, guys, welcome back to this is now the second week of Crypto Primitive Academy. The first week was all about setting up context, and now I'm going to get started working on a more real application here. And this is going to be a crypto economic primitive, which I've been calling CEPs for short. I might change that title, but you know the ultimate purpose of Crypto Primitive Academy is to find more crypto economic primitives and research that whole space and try to make some significant progress. And so today I'm going to, well, this whole week we're going to be working on this subscription manager primitive, and its role is to allow Ethereum user to set up what's basically a wallet that has an added functionality to let certain billers take out money from that wallet. A lot like how a bank account works now. You know, in a bank account you put your money in, and as long as you keep money in there, you can give service providers like Spotify or Netflix or whatever your billing info, and then they can automatically charge from your account, which is nice for the user because they don't have to worry about it. They just need to make sure that there's money in the account. In crypto, we don't really have that because everything is a push system, so no one can pull from my account. So if I want to pay for a monthly service in crypto, for example, QuickNode, if you want to set one of these up, you have to pay for a month or a week or whatever amount of time you want. I don't want to go through this. And then when that's over, they send you an email and you have to pay again. There's no automatic deduction available. And what that means is that if you don't pay within, if you don't pay before your subscription runs out, you lose the service. And especially with a service like QuickNode, where you have a node that your software is depending on, then that can be a mess. So we are going to create a contract that you can use sort of like a bank account in that way, where you can approve billers to take money out, and then all you have to do is make sure that that wallet like contract has money in it, and you know that your services will continue. So here's sort of the basic plan here. There's going to be two roles. There's the owner, which is the person who has, the pretty self-explanatory there, the person who's putting money in and can take money out. And then we have one or more billers that will be able to pull money out. The use case, I just sort of went over that verbally. The design strategy here is, I'm just going to break this up into paragraphs. First, we're just going to do a really basic wallet-like functionality. That's going to be pretty simple. Then we're going to make the data structures necessary, which is going to be a mapping to store info about each approved biller. And then we'll implement the functions necessary for the biller to actually use, take the money out of this bank account-like object. All right, let's get started. So let's go to Remix. And I'm going to clear all this out. I have this, this is the auction code from last week. I don't know if we'll ever finish this. And mostly I just don't know because I don't know if there's really a use case for this as we've written it. But we might revisit this, but don't hold your breath on that. The source code for this, of course, is on the week 1 of the Crypto Primitive Academy source code repository. So if you want to look at that or do something with it, of course, feel free. Oh my goodness, I wonder how you pronounce that. In German, so Sayron in the chat said, in German, the allowance to pull money from a bank account is called, and then there's a huge German word there. I wonder if I don't even know how to pronounce that. I want to just take that and figure out how to pronounce it real quick. Oh, I can't get it in the chat. Could you post that word again? What's that? And of course, there's a lag on the stream, so it's going to take a few seconds for him to even hear my request. Because I see the chat on my phone, but I can't copy it into my stream. There it is. I want to got to be a way. I thought there'd be an easy way to figure out how this is pronounced, but I guess there's not unless I use Google Translate. Let's do that.
Einzugsermächtigung.
Oh, you guys need to hear that. Hold up. Let me... Okay, here's how it's pronounced.
Einzugsermächtigung.
All right, and that is the word for what we are implementing. We can almost name the smart contract that. That'd be kind of funny. All right, well, I'm gonna just copy that into the post here because that's kind of a cool fun fact. All right, let's get back to the real work here. So once again, we are going to. I can't. Oh, right. Okay, so I'm gonna go pragma solidity. Of course, I always forget the syntax of this first line, so I'm just going to Control-Z and just leave that in there. Yeah, okay. And is that actually the latest version? It is the latest stable version. Okay, so I'm going to keep it like that. All right, and then contract. Okay, and just like before, this is now, I think this is compilable. So that's our starting point once again. Okay, so as I said, the first thing we're going to do is just implement the really basic wallet-like functionality. So we want to have the user able to deposit and the user able to withdraw. Well, also, I shouldn't say user, I should say owner. And we should just put that role in here, and I like to capitalize. This is my own style. So, I like to capitalize roles that there's only one of. So owner, there's only one, and I like to capitalize that. That's my own personal design choice. Although I do have a intuition that it's a good design choice. So feel free to follow that or not. But that's what I like to do. Okay, so we got an owner, and we want the owner to be able to deposit and withdraw. Now. For depositing, there's something called a fallback function in Solidity. And the fallback function is what's called when a contract actually gets ether sent to it without any kind of command specified. That's this, and I'll get the link for this section and I'll post that. I'll put that in the post here. Let's see, let me start a links header. Okay, and that's what we're going to use for the deposit. So we're not going to actually have a specific deposit function. We're actually just going to have the contract just accept ether from anyone, and just because there's no real reason. So let's when we this contract is. We're really building this for the owner, for the convenience of this owner of the contract. And I don't think there's going to be any case in which money is coming into this contract and the owner wants to reject money. No one's going to turn down money. Sometimes in contracts, you want to limit when people can send it money. And usually you want to do that if the UI is confusing or if you want to avoid people accidentally putting money into something. Or if you want to make sure that they really know what they're doing, so you require them to use a specific function. But because we're building this for this owner, the owner is sort of our primary user, I guess you could say, and the owner is always going to want to let anybody else put money into this contract, and that could be actually useful. So we, for example, for this whole academy thing we're doing, we could set up an account, one of these. SubscriptionManager contracts and let anybody donate to it, and that would be an interesting way to let people actually fund, whatever it is that we are paying for to help run the academy. So that's a couple of things. I guess I'm sort of making 2 points at once here. The first point is that we're going to use this fallback function, and I'll show you guys how to do that in just a second. But the second point is that specifically we're going to let anybody deposit this, even though we could have chosen to only let the owner deposit in, we're going to let anybody deposit money into this. And so here is what the fallback function looks like. just like that. And I believe we still have to make it payable. And let's also make it public. And again, public means anybody outside of the contract can call it, and payable means it can actually accept money. And we actually don't even need to put any code in here. Later we might add events to this contract, and then in which case we'll emit the event here, like, you know, emit. In fact, let's just do that right now because that'll be really simple. So I'm going to define an event. Let's see, what do we want to? I guess we can just call it deposit. Deposit, and it'll take an amount. Whoops, like that. And we could even say that it'll keep track of who actually sent it. Okay. So, and then we can emit that event here, deposit, and we'll say message.sender, like that, for the from, and then we'll say amount is message.value. And again, these are two special terms in Solidity. That this one returns who actually sent the command, and this one returns how much ether was included in the call. And that's actually all we need to do. So already we have the deposit functionality, and now we just need to do the withdraw functionality. Withdraw. And we need to ask how much the user wants to withdraw. I should say the owner. And we also want to make it so only the owner can withdraw. Obviously, we don't want just anybody to withdraw. We could do this in two ways. I'm just going to make some comments here to sort of put some words down for my thoughts. We could make it to where, let's see, there's two choices here that come to me. I mean, I'm sure there's actually more. But we could have it to where anyone can call this function, withdraw, but it always withdraws to the owner. Or we could have it only the owner, owner can withdraw. The first one is not a good idea because then anybody could sort of attack this by saying, okay, this guy's about to get billed, now I'm going to withdraw all the money. So the owner still gets all the money, but then it's sort of ruined the utility of this because somebody's effectively able to drain this at any point and kind of, cancel the subscriptions. So that's not a good idea. So let's go with this one. Only the owner can withdraw. We could also have him able to withdraw to other addresses. I don't know if we really want to put that in. I mean, I guess if it's simple, we can do it. But I'm tempted to not worry about it now. So we want to enforce that only the owner can call this function. And in the last few contracts I did, I just put the require right in here like this, message.sender equals owner. This time I'm going to get a little bit more sophisticated. So, oh geez, I keep hitting other buttons. Instead of putting this right in here, we're going to use the same line, but we're going to make a modifier. And I will bring up a link and post that. Solidity modifiers. Modifiers. Yes. Okay, get the link. Come on. I guess so. I'm already on it. Okay. Get the link and put it there. Okay, so there's the modifier, link to the modifiers part. A modifier is, you can use it for a couple different things, but what we're going to use it for is, as I said, a sort of a check. And once again, another stylistic thing that I like to do is include, when people write smart contracts, sometimes they like to put all the modifiers together, all the functions together, and all the events together. I do things a little differently. I like to put relevant pieces of code together. So because this modifier is very directly related to the owner, I'm going to put it right under the owner here. I'm going to say modifier, only owner, like that. Okay. And now the way you use modifiers is you can put in whatever check you want. So I'm going to paste, I don't have that in my paste, okay, I need to rewrite it. Require message.sender equals owner, like that. And then you put this underscore in here as its own line of code, and this indicates that that's when the function that's being modified should be called. So in this case, well, we also need to put the modifier here, so we'll say only owner, whoops, oh, only owner, like that. So the way this is going to work now, assuming that I don't have any bugs, let's actually just see if it compiles first. What is going on here? Oh, I need a name. SubscriptionManager. Okay, compile. Undeclared identifier. Oh, I misspelled the name up here. Like that. Okay, so that all works. Now, how this is going to work is when someone calls withdraw, it's going to enter, well, it has this modifier around the function. So before even looking at the function, it's going to go to the modifier, and then it's going to run this modifier, and whenever it gets to this underscore, that's when it's going to call run the actual function. So the way we've written it now is that we run the require before we run the function. We could have also done it the opposite way. Now technically this would work too, even though the check is running after the function, because this require function, if this fails, it'll roll back all the changes. So either way, it'll enforce what we want to do. But this makes a little bit more sense from a human readability perspective. Even though both would effectively roll back the function and prevent anything from really taking any effect, this is a little bit clearer, sort of intuitively. So we're going to keep it like that. But it is important to note that if this fails, this modifier fails with this require, whether it's before or after this function has run, because it's failed to require, every effect of the Solidity call will be rolled back. So either way, it would protect it. Okay, so that's pretty cool, and a nice benefit is it makes our function just a little bit more readable. And Solidity is great with this. You can really make your functions quite readable, even for somebody who doesn't actually know Solidity that well. If they understand programming and object-oriented programming specifically, they can sort of make sense of things if you write it correctly, write it well, I should say, elegantly. Okay, and the code on this is going to be super simple. We're just going to say owner.transfer and then amount, just like that. And that's really all we need. You know, if the user tries to withdraw more than is in the contract, this will just fail. And we could leave it like that. That would be sort of fine, although we could make it a little bit easier on the user. If they do that, they might get a confusing error message. So we can, not require, we can give them a better error message than whatever is going to be automatically generated. Because if you, I don't know if anyone viewing this has tried to use an interface where the contract has an error, but if the interface doesn't detect the error and like return that information, it's a really confusing error message. Sometimes it'll say just out of gas when really it's a totally unrelated error. So in any case, we're going to put in a require here, and we're going to say require that we want the amount to be less than the balance of the contract, less than or equal to. So we're going to say amount is less than or equal to, and remember, address this dot balance is just this is a quick way to get the balance of the contract, and then we're also going to add as a second argument to this require our message that we want to give back to the user, and that's just going to say I don't know, keep it simple, I guess. Not enough. Let's see. Requested withdraw amount exceeds subscription manager balance. Okay, like that. Now, so this require statement, I should note we didn't really put it in here to make anything safer, because this contract is going to fail, if the person's trying to take out more than is in the contract, it's going to fail anyway. The reason we put the require in here is so that we can actually return a better statement to the user. So this could make the UI easier to design. The UI could actually maybe detect this error message. Anyway, all right, so that might be all we need to do for our first point here. I'm going to actually change these into numbers. That is a little better. Okay, let's see if it compiles first. Okay, that seems good. Let's check out this warning. No visibility specified. Oh yeah, I do have a way of forgetting that. Make it public. And remember, public doesn't really mean anybody can access it. Well, it sort of does, but it could be a little bit misleading because really only the owner can use it. In this case, public just means that it's a function that's designed to be called from outside of the contract. And actually, this should really be external, not public. And I suppose this should be external as well. The difference there being that if it's external, the contract itself can't call into it. And really, there's no reason we'd want the withdraw or the deposit functionality to be callable within the contract. Okay, so let's compile it again now that we changed that. Static analysis, arrays, 3 warnings. It seems like these are always kind of useless to me. Let's just check out what it says. Fallback function requires too much gas, and this doesn't really make sense to me. I wonder if it's some sort of bug in Remix, because this fallback function is only emitting an event, which is probably it's like one of the smallest amounts of gas you can spend. So I don't know about that gas. And it says this about another one too. Well, both of them. It seems like each of our functions, the gas requirement is high to infinite. And I don't know why it's saying that, because there's no loops here. So I don't know about those. And this is just telling me more about require and assert. Okay. Close that. Okay, now we have the contract that's compiled. We're going to go run this in the VM. And we're going to deploy. Now, in one of the other seminars, I thought I had to put in a constructor here, but it looks like I don't have to put in a constructor to have this deploy button, so there must have been some other issue I was having before. Okay, so we have our contract down here. We have the fallback, and we have withdraw. It's nice that it lists the fallback. I could see tools like this maybe neglecting to give us that option because it's just kind of a non-standard function. But in any case, we can set it either with the fallback, and we can withdraw. So let's give that a shot. Now, if this was a normally deployed contract, so if we actually deployed on injected Web3 instead, we wouldn't really be this fallback, to initialize this, to run this functionality, we wouldn't really be using it like a function. We would literally just be sending ether to the contract, and that's what would trigger this. Since we're in the JavaScript VM and it's not really on a contract, we can't do that. So instead we have this fallback function. And all we really need to test here is that we can put money into it. We need to test that the owner can take it out, and we also need to test that nobody else can take it out. So, and I've just realized an error here. And maybe you guys can guess what it is. I forgot to set the owner. So we have an owner role in here, but it's never actually set. So I'm going to close this, go back to compile, and add that bit in here. And I'm going to put it right here. So we're going to actually make a constructor. Constructor. And I could take as an argument the address of the owner. That would enable someone to create a deposit address, or sorry, a subscription manager for somebody else, which I'm sure somebody could use that for some use case. I'm not going to do that now, just because by leaving the constructor with no arguments, it makes it it'll make it a little easier to handle, a little easier to build an interface around. We can always add in that functionality later. So constructor, and we're just going to say owner equals message.sender. So that basically means whoever creates this will become the owner, and that's what we want. Okay, let's compile it. I have a warning saying that no visibility specified. Just like last time, I'm not going to put the visibility in here because it does default to public, which is what I want. And I don't think it makes sense for constructor to have any other visibility. So to me, putting public in here like that just seems kind of redundant in some way. If anybody can think of a good argument for putting it in there, please let me know. But until I hear that, I'm not going to be doing that. So compile, got some static analysis, and got that warning, which we're going to ignore. Now let's go back to run and deploy it again. Okay, so now it's deployed, and the owner should be set to this first account. So you see I had this first account selected when I hit deploy, and so that's where the gas came out of. You can tell because there's less ether in there. So let's, oh, and I've noticed one more thing I need to change. So I'm going to close this, go back to compile, and that is that an owner should be public, like that. And that, when we compile now, when we go to run and deploy, now we can have this owner getter that's automatically generated for us. So now if I click this, it should return our first address here, and there it does, XCA385, and that's our address right there. So that's good. The owner is correctly set to our address, our first address here. So now we want to put ether into it. Let's put one ether and click the fallback. Again, I'm going to click fallback here. If this was deployed on a real blockchain, we wouldn't really be clicking on any kind of function. We would just be sending ether straight to the contract. Okay, that seems to have run with no errors, and it even made a log, which it should have done. Let's go just check that log. It formats it a bit oddly, but there it is, event deposit, and then args. It has 0 and 1. I don't know what these are, but it has from and amount. I believe the 0, 1, and the length are sort of metadata for the event. It's not the user-defined variables. In any case, we have the amount here and the from here, and those both seem to be correct, so that's good too. Okay, now let's see if we need to test two things with our withdraw function. We need to test that nobody else can withdraw, and we need to test that our owner can withdraw. So I'm going to test the negative of that first. So I'm going to go to a different address, try to withdraw some amount, and then that should fail. So let's see, here's the amount, and that is 1 ether. So I'm going to put that in here and try to click withdraw and see what happens. Need to minimize this. Okay, so let's see, that doesn't really give us, that's just general info we don't really need. We could debug if we want. Why don't we just do that just to see how it all went. Next. Require message.sender equals owner, and that's where it fails, just like it should. Okay, so that's good. Now let's test to make sure our first account can. Oh, and by the way, just a note on the way contracts work. Even though it failed, you see our account here had to spend gas to see that it failed. So that's something that is just, that's how Ethereum works. If you call a function in a smart contract and it fails, if it actually gets mined in a block, you still pay the gas fee for that action. Anyway, so let's go back to our first account now and see if we can withdraw. First, I'm going to withdraw more than I should be able to and see if our error message comes through on this interface. This functionality where you can send back an error message is pretty recent in Solidity. It's just one of the recent Solidity versions that's supported it. So some of the interfaces and other tools in the industry don't actually support it. So I'm just going to do this just to see what happens here on our remix output. Hey, that's pretty cool. So it does give us the message here. Requested withdrawal amount exceeds subscription manager balance. And if we didn't have that, this would be really confusing. So, if we could imagine that this was the original amount, if I'd accidentally put another 0 here and I clicked withdraw and it didn't work and I did not have this error message, I would really have no idea what went wrong, and I'd have to go debug it. But of course, I have that privilege of debugging because I'm the the developer. If there was a user, or if there was someone wanting to directly interact with the contract without some kind of interface, they would have no idea what went wrong, and they'd have to, I guess, suppose they'd have to go find a debugger and get the source code, and it'd be a headache. So it's this this functionality to put error messages back with your require or asserts is it's great. Anyway, okay, so I believe this is the correct amount. Let's click withdraw. That seems to have gone correctly. And yeah, indeed, our first address now has the ether back. So this all seems to work correctly. I'm going to add in another event here. Let's see. I want to add an event for the withdraw. Withdraw. And we're just going to do message.value, because if it's a withdraw, it will always be the message.sender initiating that. And then I'm just going to put another thing here, event withdraw unit amount. And I'm not going to test that. That's pretty simple. I'm just going to keep going. We don't need to test that specifically. Okay, so number one is done. I'm just going to put some cross throughs for that. I don't think oh, here we go. There we go. Okay, on to the second one. Now we need to create the data structures necessary to store the info about each approved biller. So let's get on that. Let's see here. So for each biller, we want to be able to store, I suppose we want to store their address, and we want to store how much, what their rate is that they can withdraw, how much a month or how much a week or whatever it is. And that's really about it, although we would also want to store the last time that they withdrew. So that way when they try to withdraw again, then our contract can calculate how much they're actually owed. So that's three things off the top of my head, and we're going to make a struct to store the stuff. So let's go after all the owner stuff. And in fact, this is a little bit experimental. I'm going to put a few lines here and leave all this code together, because it all has to do with the owner. And I'm going to put some new code down here for the billers. And at the end, we might reorganize all this stuff, but that's how I'm going to organize it for now. So we want a struct, and we want, what should we call this? It's just a biller info, I suppose. That'll work. Or we could even just say biller. I mean, why not? Struct biller, and then what do we want in here? As I said, we want who they are. So address. I mean, I almost just want to say address, but what do we call who they are? I suppose agent we could say, or yeah, it's tough when you want to name something and the best name is actually just already a keyword. It'd be nice if we could just name an address, because then we could say something like you know, biller 0.address, and that would make sense. But we can't, because that's a keyword. Well, maybe we can, but it would be bad to, even if we could, it would be sort of a bad idea to. So I guess for now I'm just going to say biller address, although later that'll end up making for some kind of awkward code, readability of the code, but at least this way it'll be more explicit, and I'd rather err on the side of being over explicit rather than having things be confusing. Okay, now we want a billing rate. Now I'm going to make this u integer unsigned int. I'm just going to call it rate, and I'm going to talk about this later, how we're going to think about that. But before getting there, I'm just going to also add in the like that. Okay, so one thing to note is there's no date variables type in Solidity. You have to store it as a u integer. But again, u integer is huge, so it can it's big enough to store any amount of ether, even and it's actually storing the amount of way, way being WEI. So that's a huge number. Anyway, let's see. So we have a struct biller. Now we want to make a list or an array. Well, let me think about this. If we're going to make a mapping, we might not really need to store the address of the biller in this struct. I'm going to comment this out because a mapping takes one type and maps to another type. It's just like a dictionary or an associative array in any other language. And in fact, I will just find that on here. Oh, go up. Oh, I thought, okay, I guess types is what we want. It's going to be in types. Mapping. Nope. Mappings, there it is. Okay, take that and put it in the post. So there's that for you guys. But the short story of a mapping is it's really just a dictionary, and then it's strict on types, so you always have to go from one type to another type. And the way we're going to do this is we're going to say address to biller. So this mapping will take an address as a key and map to a biller in the mapping, like that. And now because we're actually already identifying with the address, I think we don't need this line of code. I'm just going to go ahead and take it out right now. We don't need to store the address of the biller in the struct itself. I believe. We might have to go back and change that, but I think that's how it'll work out. So I'm going to do that for now. Okay, so there we have a mapping, and that should work. I'm just going to make sure it compiles. Nope, not yet. Oh, I need to name my mapping. I'm just going to say billers. It's pretty simple. Let's see if that works. There it goes. Okay. I have a warning here. Let's see what that is really quick. Oh, yeah. Okay. So the error is I'm asking for the message.value in a non-payable function. And so that was my mistake. I didn't really mean to say message.value. I meant to say amount here. So that's good. Good catch there, compiler. Okay, and this warning again is just talking about no visibility specified, which I'm going to ignore. Okay, so we have this list of billers. Now we'd like to have some way of adding billers to the list, which is a functionality that the owner is going to want to be able to do. So let's do that right away. I guess we just want to say add biller. We could also call it approve biller or approve rate, something like that. And well, so I'm thinking what we're going to want to do is we want really two functions, right? Two things that the owner can do. Owner should be able to approve a biller. There's a few things. I'm just going to, like, for a rate, should be able to remove a biller, and more generally, it should be able to change the rate of billing. I mean, ideally these would all be possible through this interface. You should be able to say, okay, Spotify can charge me $5 a month. You should then be able to say, okay, never mind, I don't want Spotify. Or you should also be able to say, okay, Spotify can now charge me $10 a month if you're going to upgrade your plan. And we can do all of that, I think, pretty elegantly. I was initially thinking we would have two functions, approve biller and then disapprove biller or remove biller or something like that. But I think if we just make a more general function called setBillRate, bill rate. I guess setBillRate is good for now. Address biller and event. Oops. Although that might have issues as well. No, that'll work. Okay, so that and this will just pretty simply. Well, first let's say who can do this. Only the owner, right? First of all, only owner should be able to call this function. And now you can see how convenient this this modifier is. That's really simple to put in. We don't need to worry about miswriting our require statement because we've already tested the require. We've already tested this modifier earlier, so we know that this is just as dependable as our earlier test. We don't need to go and retest that now. Okay, now we're going to go here and say, now we're going to use the mapping. Again, use this just like an associative array, so we're going to say biller, and that is our address here. In fact, I'm going to make this a little bit more explicit. Address, biller address, like that. Address. Now, so of course we want to do this. New rate, like that. It's a little bit of a complexity here, and that is that if we change the rate and the biller has withdrawn, like let's say the biller has processed a withdrawal from this contract a week ago, and we change the rate on them, we increase the rate. If the last withdrawal time has not been changed, then the next time they bill, they're going to be able to bill the new rate for what they haven't withdrawn from so far. If that makes sense. I'm not sure how clear that is, but what I'm trying to say is that if the biller has some unprocessed time that they haven't billed for yet, and we increase the rate or lower the rate, the next time they come and bill, that new rate is going to sort of retroactively apply to everything that they haven't billed yet for, which we don't really want that. We'd like for the user to be able to change the rate and have it effective immediately and not have this weird kind of retroactive effect. And so to do that, what we want to do is, now this is a function I haven't defined yet. We're going to get there. Let's call it biller withdrawal. The biller is going to have some kind of withdrawal function. And I think that when we set bill rate, which is something that the owner can do, we will just trigger a withdrawal for the biller. And in fact, we'll do that before setting the new rate. And internally, this should sort of purge and pump out everything that the biller is owed. So that way, this will sort of reset the last withdrawal time to now. And we'll see that later. And that way, when we set the new rate, it'll be effective immediately and won't have any kind of retroactive effect. Let me know in the chat if that doesn't make sense or if you guys have any questions. But if I don't see anything in the chat, I will just move on here. So maybe I guess I just, yeah, I can define later. So this won't compile yet. But before getting to defining this, let's see if there's anything else we need to do here. So set bill rate. I think that is all we need. And I think the way we'll treat this is that if the user or the owner sets the bill rate to 0, that's effectively disapproving any kind of biller. And later we'll have some checks to make sure when the biller tries to withdraw, if the rate is 0, we'll just cancel or revert and maybe give them a friendly error message saying something like the user has not disapproved you. Okay. Is there anything else? So this should be able to, this should work. Oh, let's see what this is. Oh yeah, right, I just talked about how that's not defined. I'm going to comment this out and just see if everything else compiles. We have a warning, probably about visibility. Yeah, we want this to be public. I suppose we want it to be external. And let's compile it. Okay, no errors, that's good. So let's see. so this, we now have a way to sort of populate our billers mapping. The way that mappings work, and I would encourage you guys to read through this mapping bit because it's a little weird and confusing. As far as your Solidity code is concerned, when you create a mapping, there's this, so address is our key here, it's our key type. There's sort of this field of keys, you could say, and it's sort of like it initializes every address to the null value of biller. Of course, it doesn't actually do that because there's so many addresses that would be ridiculous. But so in this case, let's say the first time we call setBillRate for any biller, the mapping billers at the biller address is going to be uninitialized. But to Solidity, it will just look like a zero, like a null biller struct. So it'll look as if rate is 0, last withdraw time is 0 as well. And even though behind the scenes the assembly is probably creating a new value there, in the Solidity it will look like there is something there and it's just set to the null value. And we'll see that a little bit later when we later check and actually start using this. But for now, just know that we're sort of assuming it exists there and assuming that if we're accessing it for the first time, all these values will just be 0. Okay, so we're going to set the rate to new rate, and we're also, well, no, that's all we need. Okay. So now that we have a way to populate billers, or at least set one of the billers to something, let's go ahead and test this. We'll compile it. We'll run it, and we'll just make sure that we can actually access the value that we set. So I'm going to go to deploy, and again, I spent the gas from my first account, and that is now the owner, my first account here. We have everything we used to have. We can check owner, make sure that's correct. Now let's use this function here. I'm going to go ahead and say that this second address here is our biller. So I'm going to copy that address, go back to our first one, our owner, and put that in as this first argument here. And we see the second argument is new rate. I'm just going to say 1 just to have an argument. And I haven't even really talked about what this rate means. This could be ether per second or way per month. We'll talk about that in a little bit. But first, I'm just going to run this function just to make sure we can actually populate this like we want. Okay, let's click this. That seems to have worked. And so now we want to, once again, okay, I need to make this public. So I now have to close this and recompile. So start to compile, and let's redeploy, and now we have a biller's getter here. So let's do that again. Let's take our second address here, copy it, reselect our first address, and we want to set the set bill rate for that address for 1. And we're going to run it. Okay, now, so billers is a getter. It's a mapping where the key type is address, so we need to give it an address to actually get back the value at that amount. So I'm going to just paste the same address here, which is our biller. I got a Slack. Oh, seminar chat. That's where I should be anyway. Thanks, Aaron. Yes, yeah, I should have probably said that earlier. So the idea here is that every user, and I am assuming you mean owner, every person who wants to create one of these will get their own contract. And yeah, we'll have a front end that will allow you to, the front end won't be locked to any specific contract. It will allow you to create your own, and then it'll let you manage that contract, which is your own. And then when you go to a biller, the idea is that they will give you their address, their billing address, the address that they'll use to interact with this contract. You'll go to the web front end, which will be public, and the web front end will be pointed at your contract, which you will be the owner of. Then you approve the biller there, and then you give them some sort of identifier to be able to go to that contract and and withdraw from it. And then as far as the billing interface goes, there might be a lot of work that we could do to actually automate that. I mean, maybe we could build some sort of system that the biller could use that would iterate through a bunch of different users' subscription manager contracts and call a withdraw function. So yeah, I hope that answers the question there. Okay, billers, let's get that. And okay, we've set the rate correctly, so that's good. Now I'm going to define this biller withdraw, and that should actually be biller withdraw like that, because that's what we want to do. And then that might sort of make where I'm going a little bit clearer here. I am going to erase these comments. And biller withdraw, let's see, let's put that here. Function, biller withdraw. And when a biller withdraws, we could allow them to withdraw a specific amount, but I think in most cases they'll just want to withdraw everything they can. And maybe I should just change this to, whoa, I didn't mean to do that, cancel that. I'm just going to change this to bill. That's what they want to do. And the idea is that a biller is calling this. So the first thing we want to do is say address, biller address equals message.sender. And then we're going to say, we're actually going to check to make sure that they really are approved for some amount. So now once again we're going to access this this mapping, and we're going to say require billers at biller address dot rate is greater than 0. Okay, so again, this mapping to Solidity, this biller's mapping is going to look as if it's defined for every address, but it's set to null values for every address. And so if someone calls bill and their address has not been registered, they're gonna find that rate is the null value, which is 0, and this require statement will fail. It will also fail if we set the rate back to 0 at some other point. So that is how you can that's how I've come to handle mappings and the idea of null values, or whether someone is approved or not. You can look at something like the rate, and if the biller rate is set to 0, that's sort of like saying either they've never been approved or they're no longer approved, and that's how we can prevent someone from trying to bill this contract when they're not allowed to. And again, if we just left this out, it would effectively do the same thing because they withdraw 0, as we'll see later. But this again makes it more explicit, and again we can even make it extra explicit with a error message returned, and we could say, let's see. You are not approved to bill from this I'll just keep it like that. You are not approved to bill. Okay. All right. So now we know if we get past that require, we know that the biller struct at the biller address in the mapping has a rate, some non-zero rate that they're allowed. And now, okay, let's talk about this rate a little bit. This rate is going to be some amount of ether per some amount of time, and so we could, we have some choices here. We could do ether per month. We could do way per second. I would like to use way per second. Well, that's my initial urge, because way and second are both the smallest amounts of time and ether respectively. But before we do that, I want to actually see what that works out to in ether per second or US dollars per second, to see if that's reasonable, because when we do the math here, we might find out that that's actually way too, it's not granular enough. It doesn't have enough resolution. But let's just do that math. So let's go to our ether units again. It's so silly that I have two of these. I'm just going to delete one. So that's how many way is in ether, and I'm just going to pull up a calculator and figure out what do I want to figure out. I want to figure out how much USD is in a way, but that's going to be such a small number. It's going to be whatever. What's the price of ether? It's like 450 last I checked. I'm just going to put 500, but that's going to be a huge number. I mean, it's going to be ridiculously, a small number, I should say. It's going to be a really small number. So I don't really even need to do this, but it's just crazy. It's basically zero. My calculator's saying it's zero. So that's not going to work, because you want to be able to. No wait, that's good, because then if we put a large amount of way per second, that's going to equal still a small amount of value per second. So that's good. That actually gives us a high degree of resolution, right? Because if we have, let's say we have 1,000, 10,000 way per second, that's still going to be a very small amount of value. So we could just, when we decide what the billing rate is, if we just put in a large number, that's going to eventually equal like $1 or something if we put enough zeros in here. So that indicates we have a lot of resolution here. So I'm going to keep it as ways per second, and I'll just put a comment here making that clear. Okay. So now we need to, let's see here. I'm just still thinking through the way that bill is going to work with the new rate and setting the withdrawal time. I'm going to ignore that for now and just finish out this function bill. Okay, so we got their address. We've seen that they actually have some rate, and now we need to figure out how much time that they're allowed to bill for. So uint billable time, and that's going to be now minus last withdrawal time. Now is a keyword in Solidity. Just it gives the number of seconds that is happening when the block gets mined. And last withdraw time should have been set to now, the last bill cycle. Okay, and then we can say uint billable amount equals billable time times, and then we get the rate, biller address dot rate, like that. Okay, and then we can say biller address dot transfer to actually send that out, billable amount, and then we can say that we want to finally set the last build time to now. So biller address dot last, and I should change this to last build time. I'm going to do that right up here. Last bill time equals now. So for now, assuming that setBillRate is never called again, and that's just a temporary assumption, we'll fix this in a moment, but assuming that setBillRate is called once and then the biller is going to bill repeatedly, this should allow the biller to call, bill, and they will get returned whatever they're owed, based on how long it's been and what the rate is, and then it'll finally, and then at the end, the last step here is it will update this last bill time to make it to where the next bill also functions correctly. So let's just make sure that works, and then after we make sure that works, we'll go back and see about making sure that when we set bill rate to a new rate, it works correctly with updating the last build time and all that stuff. I have a Slack notification. We only have to really protect against re-entrance if we call outside of a function, and you'll notice I'm using, first of all, it's a good question, thank you for asking. You'll notice I'm using transfer instead of send, and transfer basically protects against re-entrancy. If I use, I think, call or send, and I should maybe just look this up just to give you guys a link. Call, transfer. I wonder if I already gave you guys this link in a previous seminar. Yeah, so when you call, and I think when you send as well, although I'm not sure, but certainly when you call, that allows, if what you're calling is a contract, that allows the contract to do any sort of arbitrary code, which includes calling back into your contract, and that's where the re-entrancy happens. And by using transfer, that function prevents re-entrancy because it doesn't actually give enough gas to who you're sending the ether to do anything. So again, back to this payable function here, or the fallback function is what I mean. This function gets run whenever it gets sent ether. So if the re-entrancy issue is that imagine this is some external contract. Here I could put another line that calls back to whatever contract called it, and then that's where it has re-entered the contract. But again, you can avoid that as long as you use transfer, because transfer doesn't give enough gas to the called contract to do anything. And so that is a very simple way to protect against re-entrancy. And there are other ways as well to protect against re-entrancy. And if we wanted to, for some reason, if we wanted to have this biller address, if it was a contract, if we wanted to allow them to do some arbitrary code stuff, then we would use call, and then we'd have to then move on to some more advanced ways to protect against re-entrancy. But for now, this is a very simple way to protect against re-entrancy, and the only downside is that then the biller address can't be a complicated contract that would want to react in some way to receiving this ether. But as long as, even if it's a contract, it can receive ether here, and it can even make event logs, I believe, or emit events is what I mean to say, and they will still return correctly. It's only when it uses more than that small amount of gas that that you have to worry. Okay, so oh, and I want to put some visibility on this bill. That's going to be an external function. So let's go ahead and test this as it is. Got an error, of course. Last withdraw time. Oh, that's from the mapping here. That. No, didn't work. Last not found. Oh, last build time, right. I renamed that. There we go. So here, well, so here's the issue I'm running into. What I'd like to do is, when you set bill rate, you would want to say biller address dot last bill time equals now, because again, this is going to be 0 unless we set it to something, so we need to set it to now, and that way the next time you call bill, it knows when you set the bill rate, and then it knows how to, it can calculate the correct amount to send to the biller. The problem is now we're back to this issue I was talking about before, where if you set the bill rate and they haven't billed, it's going to retroactively. If they haven't billed recently, it's going to retroactively allow them to charge more even before you've called this. And one way we could fix this is by calling bill, although, well, that doesn't work because the message.sender is going to be the owner because we're calling it from this. So what we can do, what we want to do is if we set bill rate and the rate is already non-zero, so there's already been some rate approved, we would like to be able to send whatever's left over to the biller and then set last bill time to now. So pump all the money out of it that they're owed, set the new bill rate, set the last bill time to now. Again, this is assuming we've already set the bill rate once and the biller might or might not have billed. And that way that we can solve that retroactiveness. You don't want to repeat code. I could repeat some of this code from this function and put it down here, but instead of doing that, it would make more sense to maybe create a third function that both bill and set bill rate call. And so I am going to do that. I'm going to call it process bill. Function process bill. And I want to make this internal. So only the contract can call it. And then I'm going to take some of this code from this function, put it up into process bill. And then I'm going to call process bill from both this function, which I might rename, and this function. And that way each of these functions will call the same bit of code, which will actually do the meat of this function here. Okay, so process bill, and I'm going to have this take as an argument biller address. So that way we don't need to grab the address from message.sender because it would be something different if process bill was being called from setBillRate or from bill. We're going to actually have it explicitly passed to this internal process bill function. So I think then all we need to do is take all this from here. Let's actually leave that require statement in this one too. So let's take all this, put it in here. And then here, let's do process bill. Address like that. Okay, so as we've written it now, bill still does the same stuff. We've just moved the code from here, from this function into the new function and called that function from bill. I'm also going to rename this function now that we have a couple of bill functions. I'm going to say call bill. Starting to sound like bill is a weird word because it's also a name. Sounds like we're trying to call bill a person. But anyway, yep. Okay, so now that we have this internal function called process bill that takes whatever the biller is owed and basically settles the debt, we can call that from call bill. We can also call it from set bill rate. All right, and so the first time set bill rate is called, it will call process bill for the biller address. And if it's the first time set bill rate has gone, then the rate is going to be 0. So it'll go through this code, and it will say it'll get the time, which will be a huge amount of time because now is also 0. But when it calculates the amount, this will turn out to be 0 because we're using this rate here. So we can leave it as it is. I'm just going to go and make it a little bit more explicit. Explicit is always best with these smart contracts, especially when we're better call bill. especially when we're making, if we're trying to make cryptoeconomic primitives, we want to make this code explicit and easily readable. So I'm just going to say if, let's see, biller address dot rate equals 0, then we're just going to say that we can just return, although, well, no, we don't want to do that because we still want to run some of this code. What do we want to skip? So let's do this. If it's not 0, then we want to do all of this, right? If there's already a rate here, then we do want to actually make sure there's money going out. So we need to figure out how much money there is and send it out. And then, but either way, whether it's 0 or not, we want to set the last bill time to now. So we process the bill. If the rate is 0, don't worry about doing all this. We don't need to figure out how much billable time they have. We don't need to figure out what the billable amount is. We don't need to transfer anything because we know this is just going to turn out to be 0 anyway. This will also save on gas, which isn't too big of a concern because it's pretty low gas anyway, but yeah, it's always good to save gas. And especially, Ethereum might not remain very cheap for very long. I mean, it's already it seems like the gas fees on Ethereum are becoming more and more often high. We might be close to seeing the end of cheap gas for Ethereum, at least until some sort of scaling solutions come into place. Anyway, so now we have this process bill internal function, and if the rate is not 0, it will figure out how much to send to the biller and send it out. But either way, whether it's 0 or not, it will set the last bill time to now, and that is good because now we can use it in both of these functions. So that should be all we need to. I guess that's really all we need, I think, to enable a biller to withdraw successfully, and also enable the owner to not only set the bill rate initially, but reset it later and know that that there's not going to be any weird retroactive application of the new billing rate to any unbilled time. A slight side effect of that is that this biller might sort of unexpectedly get some if the owner calls set bill rate to a new rate, then the biller will sort of unexpectedly get whatever is left unsettled in the debt. I think that's fine. No issues there. I mean, it might be a little confusing for a biller to maybe randomly get a deposit that they don't notice, and then they go try to bill, and then the number is not what they expect. But again, some of that complexity and weirdness can be handled in the interface. The interface can be really intelligent as far as how to use this primitive, and we want to keep this primitive as simple and basic as possible. We want it to be primitive, and again, we can revisit that behavior at a later date, but it's best to start simple with what we're trying to do, make these primitives. So let's see if it compiles. Okay, compiles, that's good. And let's go ahead and test some of this stuff. So let's deploy it. There we go. And so what do we want to test? I guess we want to, let's start using some real numbers for the bill rate. So I'll have to get my calculator back out. Let's sort of imagine that we are going to set up a Spotify account. Or, well, let's do QuickNode. So we want to approve somebody. I guess it doesn't really matter. Let's imagine there's a biller, there's a service we want, and they want to be able to charge, I don't know, 0.01 Ether. What is that? That's like $5. They want to charge $5 a month. I guess I should start writing some of this down to make it a little bit more visual. So biller, let's say service provider, wants to bill 0.01 ETH a month. Okay, so now we need to work that down to Wei per second. And again, this calculation we're about to do can be done in the should be done in the interface. Fuck. Interface. That. Okay. So let's get that calculator back out. I don't have it up anymore. So, well, first let's go here and get 0.01. Oh, come on. Oh, this is annoying. There we go. That's how much way it's going to be. Okay, now we need to divide this amount down until we get the amount per second. So to do that, let's take this, paste it, and now we're going to divide by, okay, 30 days in a month divided by 24 hours in a day, divided by 60 minutes in an hour, divided by 60 seconds in a minute. And there is our way value. I'm just going to truncate that. Okay, so there's our value that we're going to put into our billing contract for the rate. And again, this math is going to be done by the interface that we build later. So let's go back to Remix, and I want to set bill rate. Again, we're going to take our second contract address. That's going to be our biller. Put it in here. And then for the bill rate, now we're going to actually take this number, which represents 0.01 Ether a month. Okay. And set bill rate. Okay, that went correctly. Later we can also add in some more events here. I'm not going to focus on that too much right now. All right. Now now we need to first, let's just see if the biller can withdraw. Let's see that. Let's see. Okay, we need to now go to our biller account. This is registered as our biller, and call bill. We need to call bill. Better call bill. So it should be just this simple. I shouldn't need to specify anything. If I click this as the biller, the contract should see how many seconds have gone by and give me the correct amount of way. And we'll be able to inspect the transaction just like this when it comes out and see the value and see what happened. So call bill. Oh, didn't work. Okay, so now let's debug and see what happened. Debug. So let's go back to the beginning. Okay. Biller address equals message.sender. Require the rate is equal to 0, greater than 0. Wait a minute. Yeah, that should pass, right? Okay, it did. Now we go to process bill. Okay, now we're up here. We get the time set. I wonder if we can see. Oh, billable time is 0 here. It should not be 0. Got a message on Slack. Oh, yeah, there's no ether. Yeah, well, that will certainly make it fail. That's true, Sayron. We didn't actually put anything into this billable contract, so I bet as we go on, that'll be what fails. Transfer. I bet this. Yep. Oh, wait. I don't know what it's doing here. This seems weird. It seems like a bug in the debug thing, because that doesn't make sense that it's going up there. Well, in any case, certainly it would fail if there's no ether in it. So let's put ether in it and then try that again. So again, we're gonna. Well, it doesn't matter which address we deposit from. We just need to send ether to it. So 1 ether, fallback. Again, this is just like sending ether to the contract if it was on an actual blockchain. Okay, now there's 1 ether in there. Now we're still on our biller. Let's try call bill again. Hey, and it works. So Sayron, you were totally correct. Well done there. Okay, so now let's go look at what actually happened and make sure that it transferred the correct amount out. Oh, it doesn't say in here. oh wait, here we go. So if this was a blockchain transaction on Ropsten, we would be able to look at Ropsten and see the internal transactions. I would, because I'd like to see the exact amount that it sent out. I don't know if I can. Yeah, this is not telling me what's actually going on. Well, I guess we could just put it on Ropsten and test it, start testing it there. That's nothing wrong with that. We just have to wait a little bit longer between transactions. So I'm going to do that. Let's see, close that. And I'm going to go to Injected Web 3. I also need to unlock my MetaMask. Go to Ropsten. No, I believe the seconds work correctly. I believe that the now thing works correctly in the VM. Well, the function worked anyway. We just, the only issue I'm having now is that I'd like to be able to inspect it, and I don't think I can't inspect it, I think, through this interface. So I'm going to put it, compile it, and put it on Ropsten directly, and that'll give us access to a lot more tools. The only downside of that is we'll have to wait for it to mine whenever we do something. So I'll go deploy, MetaMask pops up, I'm going to confirm. Click there, and we will just wait for this to mine. I'll be right back, gentlemen. Maybe in 2-3 minutes. Okay, I'm back. Let's refresh, see if this has gone through. There it goes already. Okay. I had to put on a sweater. It's cold in here. So, we got the contract created right here. Now let's use, in previous seminars I've used my Ether wallet. I'm going to start using my crypto instead. It seems to be the one that will actually see active development. It's made by a part of the same team, and it does basically exactly the same thing. Let's see, I want to go to Ropsten, which I thought that it would automatically, well, it does say, whoops, didn't want to do that. It does say auto, so we'll just see when I connect to MetaMask. I bet it will change to Ropsten. There it goes. Okay, now I want to go to contracts. Yeah, that's fine, I guess. And okay, just need the address and the actually, you know, okay, I could use my crypto. I am going to go to with Pragma and show you guys how this can be used to interact with contracts as well. So in My Crypto or in Pragma, if you want to use a contract, you'll have to give it the address and the ABI. I mean, any interface that interacts with a contract will need those two. But Pragma will, you can already see I have some contracts here. It's much easier to manage contracts. You can interact with them, and it even shows you the event logs. It's a really nice development tool. So I am going to use this, unless it gives me some issues. That's the problem with this site. It's new. Sometimes you run into bugs. I like to use it whenever I can, because if if it doesn't have any bugs, it's really a slick interface. So let's take the address from here, put it here. I'm going to also name it Subscription Manager, like that. And then I'm going to take the ABI from Remix. And again, it's a little weird to find. You got to go to Compiler, make sure you're selecting the right one, go to Details, and then copy ABI right there. And we'll paste it like that, submit. Okay. Now that we have this, we can go here and we can go to Interact. One of my favorite things about Pragma is that you get this automatically generated interface, which, I mean, that's nothing new, really. I mean, we sort of had the same thing on Remix, although it's a little bit nicer to look at here. But what's really cool is you can click this shareable thing. And this is cool because now I can take my link here and I can give it to you guys on Slack. And anybody can now go to this link, and you guys can actually interact with the same contract that I'm interacting with now. And what's great about that is that this is an automatically generated public interface to any smart contract that's out there, as long as you have the address and ABI. So that means that now I can create a contract, and without even touching JavaScript or Web3, I have this interface here that people can sort of help me test out the contract with. That's really cool. There's a lot of gotchas and downsides to these general interfaces. For example, this bill rate, all it knows is that it's supposed to be a UINT 256. And this thing is not ever going to be intelligent enough to say, oh, that's supposed to be a date. Let me choose a date picker. Or, oh, that's an amount of ether. I should ask for an amount of ether and convert it to Wei. So that's sort of the downside of this kind of interface. But still, we get a lot for free here. It's quite nice. And we could have used My Crypto too. Again, because it's on Ropsten, our contract is actually on Ropsten. It's accessible from everywhere. And so that's a benefit we're never going to get by using a VM, and or by using any kind of, a lot of these IDEs that people use for contract development, like you test them around in your own little test net, but you don't easily get access to all of these third-party tools. Okay, so we have this new billable contract out there, and we can first, let's look at the owner, because I deployed it in a different way. Because I deployed it through MetaMask, it'll probably be my first address here, my main address. Let's just click submit, see what pops up. And there it is, XC835. Is that what mine was? 8, yeah, and it ends in 46. Yep. Okay, cool. So that means my first MetaMask here is the owner. And billers, I could put in an address. Just so you guys, here, I'll just show you guys this. I can take any address here. I'll even just take my main and put it in. It'll just give me 0 values. And so as you can see, it appears to the contract as if there is something there and it's just set to zeros. In reality, that's not actually the case. But as far as we're concerned as programmers, that's how it works, is that the entire biller's mapping is defined, but it's defined 0 everywhere until we start defining it as something else. Okay, so what were we testing again? Let's close My Crypto. We're not using that. I'm gonna close this as well and close that too. So if we go back to our code here, we want to first, let's put money in, and then we want to test to see if the biller can take it out. we'll put money in, we'll set the bill rate, and then we'll try to withdraw. So, and you can see also that the interface splits things up quite nicely. You have your getters up here, your setters, and then we have the fallback function. It wants me to put in the amount in way, which is kind of annoying, but that's okay. I guess let's open up that ether units again. We're going to put in 1 ether. Submit, although I don't think I have one testnet ether. I don't. Okay, so I'm going to take a 0 off, take 2 zeros off here, so that'll be 0.01 ether that's actually in the payment. Click submit. Oh no. Pragma's not triggering MetaMask. Man, okay. Well, that's... I might just have to abandon this again. Wow, that's frustrating. I wonder if there's a quick fix here. Okay. MetaMask, Pragma. Let's just see. Okay. Man, that's really disappointing. I was excited to use this interface. I guess we'll have to go to my crypto. Pragma seems to work on Windows. I guess maybe it's an Ubuntu thing. How frustrating, man. Okay, well, I'd be curious to see if you guys can use these. I copied the link into the Slack. If you guys could just go here and, let's see, I guess just use one of these setters here or fallback and just try to put in some Ropsten ether. So you'll need MetaMask on Ropsten, and just put in, you can even just put in a 1 here and just click submit and see, when I click it, MetaMask should pop up, and it's not popping up. So I'm curious to see if you guys can do it. Please let me know on the Slack. For now, I'm going to move on and use my crypto. It's really too bad. I'll have to, I guess I should submit a bug report or something. Okay, contracts. Once again, we're going to get the address. Let's see, where'd the address go? Put the address, get the ABI again from Remix. Okay, now we have our functions we can call. Let's see what the owner says. Owner is null. Oh, are we on? Okay, it didn't connect to our MetaMask yet, so it doesn't know that we want Ropsten. Let's try that again. There we go. Okay, now let's. So here we can actually just send money directly to this contract. Let's do that. Where did the? Let's go find the contract again. Go to our contract deployment transaction. Click on the contract here, and let's just send money here with MetaMask. I mean, fake money, of course, but send. We're going to send 0.01, and we're going to send it to this. Next. Confirm. Okay, we'll click on that and watch it. Let's refresh. Refresh until we get some of those animations. I'm not getting the animations. Wonder if it's showing up on this page yet. Nope. Just waiting. And this is what we're waiting on right here. This transaction as was found in our secondary node and should be picked up by our indexer in a short while. And I believe that, there we go. We got some animations. I don't know if it'll show up here yet. Nope. But this should be replaced with the fuller page in a second. I don't think we need to refresh to see it. Oh, there it goes. Oh, already 5 block confirmations. So now if we refresh here, we should see it. 5 block confirmations. Wow, I guess the ROPS and testnet must have really fast mining or something. Anyway, okay, so now this contract has the Ether in it. We can actually see it here. And so now we can go back to our interface here. And as still signed in as our owner here, our first address here, we're going to approve a biller. So we need to find setBillRate, rather, is what I meant to say. And for the biller address, let's take our test Atlas account, copy the address, go back to our main. That's the address, and our rate is again going to be this number we worked out here, which was 0.01 Ether a month. We're going to put it here. And use MetaMask. And then click write. Oh, we need to. We don't want to include value. That's like if we wanted to send some Ether with our transaction. We don't want to do that. Okay, write. Generate transaction. Send transaction. Send. Confirm. Okay, so now that should be going. Once again, we can click here and watch this. See how it goes. Okay, so there's another data point. Pragma doesn't work on another Linux with Firefox. Yeah, I've tried it with Firefox on my computer as well, and I guess it's just a Linux thing. It's so frustrating because I love Pragma. I guess I'll stop going on about it because it's not working so far. Maybe the Pragma guys will eventually see this video and be ashamed and fix it, or maybe I'll give them a bug report. Anyway. Okay, that is now completed. We can refresh and see it here. So now this is our, well, we can't see much on there, but this is the actual command. This data would not be there if it was a regular transaction. Anyway, so let's, this is the same, we're that same transaction. So we've approved the biller, and we can, one thing we can do is just check to make sure that that the biller is in our structure, or in our mapping. So let's go to billers, and again we need to specify the address of the biller we want to query the information of. So I'll go here and change to test Alice, copy, change back to main, and then go paste, read. Okay, there's our rate and our last bill time also. That's probably close to what the current yeah, so right now it's 150. That's the number represented now, and that looks like it's pretty close to, let's see, 60759. This is 60862, so that's seems about right. Okay, so that seems good. And now let's go and try to bill. Finally, right? We're going to call bill. We're also going to change to our biller identity here, test Alice. And we should just be able to click write, and this should work. Let's see. Generate, send. Oh, it forces me to wait. That's kind of annoying hand holding. Confirm. Okay, now we can click right here. This will bring us to the same page as if we went through MetaMask and clicked on our transaction right here. But again, we're going to wait for this. And now when this confirms, we should be able to inspect the transaction and actually see what it sent out and what happened. Oh, input's undefined. I wonder if You know, it could be that Pragma uses synchronous functions. I've run into that before. I use all asynchronous functions with my Web3 stuff, but if with Pragma is using synchronous functions, maybe that's triggering it. It's not quite clear, but considering this is the first result, that might be it. Nothing else here is happening is helpful. So, anyway, this has now. Ooh, this one failed. So we got a failure. It says out of gas. Oh yeah, I ran into that last time. So let's go back to my crypto. Close both of these. Let's change the gas limit. And this actually does seem like a really low gas limit. Oh, can I not change this? Hold on. I should be able to generate, send. Oh, okay, I guess I need to try again. Okay, call bill. I can't change it here. I think I'll be able to change it when MetaMask pops up. Let's try. I wonder if I can change the details. Can't change anything here. Yes, okay, gas fee, gas limit. So that's what we want to change. Last time, when I ran into this issue, I tripled it. That still didn't work, and then I just made it a bigger number. I about made it times 30, and that seemed to work. So save, confirm. And now let's go again, watch this. And this is the value that I've changed. Again, gas value it gives the contract more time to process. And you won't use up all this gas you specify. It'll only use up whatever calculation the contract needed. But if it goes over whatever this number is, it'll fail. I'll be back in just a second, guys. I'm back. Still chugging along. Oh! Okay, so, well, at least we didn't get the out of gas error this time. We got a reverted error. And maybe I called it from the wrong address. Let's go look. Oh, yeah, see, it's saying from is not from our test Alice. I bet it's sending from our main. Indeed it is. So my crypto, when I click send, it's selecting the wrong address. So as I've said before, sometimes pages don't select the right address, and the only way to really get around it is to refresh. Unfortunately, that's going to clear our address in ABI, so we'll have to go grab that again. Although I wonder if I'm just going to try, I'm going to see if I can change it in MetaMask. So I'm going to go to call bill, click write, generate, send, and see that, yeah, it's saying from, that's the wrong address, and I can't change it here. I might be able to change it in MetaMask. Let's just see. No, it won't let me. Okay, so I'm going to cancel, and I want to make sure I'm on the right account. And I guess, okay, so I'm going to refresh this. I'm going to copy the address and refresh. Make sure we're in Ropsten, put in the address, go get the ABI from Remix again, access, call bill, MetaMask, and that step is probably where it loaded the correct address. Write, generate, send. There we have our address that we actually want. So that's why our transaction failed. We were trying to bill, but we were not the biller. So that's good. I mean, that's good that we were stopped in that way. And again, we need to go here and change the gas limit. Just do that again. And again, when we make an interface for this, we will be able to hard code in a different gas limit to make sure that the user's not going to have to manually do that. We have to because we're directly accessing the contract. And I guess that my crypto is not quite intelligent enough to accurately estimate how much gas something will need. So that's our old one there. Let's go here. Click on this. And wait for this to go. It should go here soon. Now we're creeping up on 2 hours. I think I'm going to continue on with this stream, maybe even up to 3 hours, because I would like to get this contract relatively complete before finishing up today. So, although if this works, this will, if this works like it should, then that will sort of, well, really we're working on 2 and 3 at the same time now. If this works, we might even be done. I guess I'd have to think about it, but that might be all we need to really do. Anyway, we'll revisit that. Okay, so success, that's good. And here, so here's what I was talking about. Here we can inspect this a little bit more. We have the overview, we have internal transactions here, but already we see here that we have a transfer inside here, and it's sending this much Ether. So let's take, okay, first of all, I guess we want to look at the transactions, manually calculate how much the biller should have received, and see if that's how much they actually got. So I'm going to keep this page open, and I'm going to open a new tab with looking at this contract. We're going to look at these transactions. We created the contract here. We put the money in here. It's the 0.1 Ether. And then so this will be when we set the billing rate. We initialize that biller, and this will be when we tried to take the money out, or where we successfully took the money out. So we have 10 minutes, or about 9 minutes between those two transactions. So if our contract worked correctly, we should get about 9 minutes of build time for that biller. So let's do the math manually first. So 0.01 Ether a month, that's the rate that we should have gotten. And so again, let's do some calculator math here to figure out how much that is per minute. And then we will multiply that by 9 and see if that's how much we actually got. So 0.01 Ether that's how much per month. So we want to get, oh wait, we don't want to divide, do we? Yeah, we want to divide. Okay, so that's per day. And so that's the amount per hour. Divide by 60, so that'll be the amount of Ether per minute. And then let's multiply that by 9. So this number should roughly be equivalent to, if we go back to this transaction, hey, that looks good. So let's see, first of all, there's 5 zeros there, and there's 5 zeros here, and then it's 2083, 2052. So that's pretty close, and that seems to confirm that looks good. I mean, that's how much the biller should have received. I guess we could also check to make sure that this is actually going to the biller address, 0x3420AA. That is our Alice, right? So yeah, it is. 34 ends in 1164. It doesn't show us what it ends in here. So that looks good. We still want to test. We still want to test the some other aspects of this. We want to make sure that if we set it to a new bill rate, it processes the bill. Although, I mean, we've sort of already indirectly tested this logic right here. So when we use call bill, because it calls the same thing, and this is the code here that actually calculates that rate that we just checked. So that this rate calculation seems to be correct. We could call bill again. to make sure that it does the same rate again. And then we could finally set the rate to 0 to make sure you can't call bill again. But I think, considering this is at 2 hours, and it looks like Sayron's heading out. He's been certainly the most active on the stream, so I think I'll just close out with him. But this looks to be complete. Let's think if there's anything else this needs to do. So the owner, they can put money in, they can take money out, and then they can add a biller by calling setBillRate. So they can set a bill rate for any address on Ethereum. They can say what the rate is, and then it will process the bill. In case there's already a rate there, it'll pump out any money that's already owed to the biller, and then it'll set the new rate. I can actually also take this out, this last line here, because that action is done in process bill right here. So yeah, I think the contract is actually done. We could do more testing, and certainly before publicizing this as complete, we would want to do more testing. But that seems to be it. There's our crypto economic primitive, our subscription manager contract, and as far as building a crypto economic primitive, where the contract is all that we're really defining as the primitive, but we still got a lot of work because we want to build what I would call a pilot interface for both the owner and the biller. Because as it is right now, of course, it's a huge pain to go and use my crypto. If Pragma was working, it'd be a little easier, but it'd still be a pain. All this math we had to manually do, all that can be done with an interface. So that'll be the next step, which is great timing because we just ended on 2 hours here, and Tuesday is when we will start working on the interface. So I think that's about it. The last thing to do is add in some events here, but I can end the stream now and just add in those events manually, and you guys will. I'll go over them briefly, the events, on Tuesday. So I think that's it. Thanks, guys, for tuning in. And check out the CP Academy website if you have randomly wandered onto this video. I'll put a link in the description, and there you can get into our Slack. You can talk to us and ask me any questions. We have still a pretty small number of viewers, so I have more than enough time to directly answer questions. Don't worry if they're too dumb. I mean, as long as you understand object-oriented programming, I'm happy to answer any questions above that level. All right, thanks, guys. I will see you next time.